Now we're ready to go. Okay.
Space-time is doomed. So is any theory of consciousness that assumes space-time is fundamental. I will begin this talk with a 3-minute summary. Science has assumed that space-time is fundamental. This has been remarkably fruitful. Most scientific theories of consciousness assume that elementary particles are fundamental objects in space-time. Particles form macroscopic objects, such as brains. Brains and other objects with the right properties give rise to consciousness, or to the illusion of consciousness. Many panpsychist theories assume that space-time is fundamental, that elementary particles are fundamental, and that consciousness is a fundamental property of particles and their combinations. However, gravity and quantum theory together entail that space-time is not fundamental. So also does evolution by natural selection. Space-time is doomed. But physicists have recently discovered the amplituhedron and cosmological polytope. These are geometric structures beyond space-time, beyond quantum theory, beyond Hilbert spaces. These structures reveal deep symmetries of scattering processes and simplify the computation of scattering amplitudes. Since space-time is doomed, physicalist reductionism is also doomed. What is beyond space-time? We propose a network of interacting conscious agents. Its dynamics is Markovian. This dynamics creates space-time as follows. We project the dynamics onto its asymptotic behavior. Some, but not all, of this asymptotic behavior can be described by permutations and convex combinations of permutations. These combinations are points in geometric objects called Birkhoff polytopes. These Birkhoff polytopes form the basic cells of the positive Grassmannian. A linear map takes the positive Grassmannian to the amplituhedron. The amplituhedron then projects down to space-time, giving rise to unitarity and Lorentz invariance. Space-time is not fundamental. It is a projection. A theory of consciousness that starts with objects in space-time is doomed to fail. Instead, we start with a network of conscious agents beyond space-time. The asymptotic behavior of these agents generates space-time and physical objects. That's the end of the summary. Now I'll jump into the talk. Our best physical theories now tell us that space-time is doomed. It is not fundamental, nor are its particles and other objects. For instance, Ed Witten says, everyone in string theory is convinced that space-time is doomed. Nathan Seiberg says, I'm almost certain that space and time are illusions. These are primitive notions that will be replaced by something more sophisticated. Nima Arkani Hamed says, the very notion of space-time is not a fundamental one. Space-time is doomed. There is no such thing as space-time fundamentally in the actual underlying description of the laws of physics. Why is space-time doomed? Because of the interaction of gravity and quantum theory. For instance, the uncertainty principle dictates that to probe smaller regions of space, you need greater energy. But in a world with gravity, at about 10 to the minus 33 centimeters, you need so much energy in such a small space that you create a black hole. You destroy what you want to probe. If you use more energy, you just make the black hole bigger. There is a second problem. Because measuring devices are quantum systems, more precise measurements need more degrees of freedom. As you add degrees of freedom to your measuring device, you will, at some point, create a black hole and destroy your measuring device. Evolution by natural selection agrees that space-time is doomed. Using evolutionary game theory, we can ask a technical question. Does natural selection favor veridical perceptions? Intuitively, we might think the answer is yes. After all, those who see the world more accurately should enjoy a competitive advantage over those who see less accurately in the basic activities of life, such as feeding, fighting, fleeing, and mating. But it turns out the answer is no. Simulations and theorems reveal that vertical perceptions go extinct. Seeing the truth won't make you more fit. It will make you extinct. What evolves are sensory systems that act more like a desktop interface. They hide reality and guide useful action. We can think of 3D space as our desktop. Then physical objects are like icons on the desktop. Or we can think of sensory systems as a virtual reality interface to play the game of life. In a VR game, I control a complex computer. I don't see the computer. I don't need to know about it to play the game. Similarly, our senses guide adaptive actions that control some objective reality. We don't see that reality. We don't need to know about it to play the game of life. Spacetime and its objects are a virtual reality. They guide adaptive action. We create them and delete them as needed. For instance, in the VR game, if I look to my right and see a red car, that car exists only when I look at it. When I look away, I delete it. Similarly, if I look through a microscope and see neurons, those neurons exist only when I look at them. When I look away, I delete them. Each act of observation is an act of fact creation. This accords with John Wheeler's view on quantum measurements. Each elementary quantum phenomenon is an elementary act of fact creation. Physics and evolution agree that space-time is doomed. Therefore, physicalist reductionism is also doomed. As Nima Arkani Hamed puts it, so the entire reductionist paradigm, that fundamentally physics is given by some laws at the ultra-most microscopic distance scales, and that somehow we just have to go there to see what's going on, is ultimately false because of gravity. Reductionism has a long history. For centuries, many thought that earth, air, fire, and water are among the elementary constituents of reality. Some thought that these constituents have small, indivisible units. Others thought that they are infinitely divisible. Then, with the success of the periodic table, we thought that atoms are elementary. Now, with the success of the standard model of physics, we think that quarks, leptons, and bosons are elementary, with behaviors governed by fundamental laws. We think that larger objects, such as pyramidal neurons, are composed of these particles. Even larger objects, such as brains, are composed of neurons and other cells. Physicalist theories of consciousness assume that spacetime and particles are fundamental. Particles form complex objects, such as brains. Embodied brains and other objects with the right properties create conscious experiences, or they create the illusion of conscious experiences. Experiences such as the sound of a saxophone, or the smell of a rose, or the taste of chocolate. But no physicalist theory has yet explained any specific conscious experience. What precise integrated information must be the taste of chocolate and could not be the taste of vanilla? What precise orchestrated collapse of quantum states in neuronal microtubules must be the smell of a rose and could not be the smell of a lemon? What precise state of a global workspace must be the middle C of a saxophone and could not be the sound of a trumpet? Physicalist theories have failed to explain any one specific conscious experience. This failure led Steven Pinker to say, but the last dollop in the theory, that it subjectively feels like something to be such circuitry, may have to be stipulated as a fact about reality where explanation stops. In other words, the failure is principled. Physicalist theories cannot explain subjective feeling. They can only stipulate it. The reason is simple. They assume an ontology of space-time and a methodology of reductionism. But space-time is doomed, and physicalist reductionism is dead. Physicalist theories of subjective feeling must fail because their key assumptions are false. Similarly, many panpsychists assume that space-time and particles are basic. They posit that consciousness is a property of these particles. but spacetime and its particles are doomed. We create and delete them as needed. So the failure of this panpsychism is principled. In short, spacetime is doomed. In consequence, physicalist reductionism is doomed. Thus, physicalist and panpsychist theories of subjective feeling are doomed. The problem is not just spacetime. Quantum theory is not fundamental. We need a theory beyond spacetime and quantum theory. As Nima Arkhani Hamed puts it, so there's some other structure that we're looking for, and some way of thinking about interpreting this structure will let us see spacetime and quantum mechanics emerge simultaneously and joined at the hip. So Nima says we need new structures and ideas that don't look anything like anything having to do with particles propagating in spacetime and wave functions evolving in Hilbert space. How can we find new structures beyond spacetime? One key is scattering. Particle colliders, such as the Large Hadron Collider, smash particles together at high speeds and detect particles that spray out. Theorists predict the probabilities of scattering events using Feynman diagrams and mathematics that assumes spacetime is fundamental. The math is complex. For example, the formula for 2 gluons scattering to 4 gluons is hundreds of pages and billions of terms. Experimentalists begged the theorists back in the early 80s to simplify the math so they could analyze their data. Then in 1986, Stephen Park and Thomas Taylor discovered a formula using spinor helicity variables that requires only one term. The Park-Taylor formula hinted at something interesting beyond spacetime. Soon, simple formulas were found for other scattering processes. In 2005, Ed Witten and his collaborators used twistors to write simple expressions called BCFW recursion relations for scattering amplitudes. This caught the attention of Nima Arkhani Hamed. The terms in these BCFW relations were coming from a different world, he said, and we wanted to understand what that world was. A breakthrough came in 2013 when Nima and collaborators united these results in a polytope beyond spacetime, the amplituhedron. Its volume encodes scattering amplitudes. Its structure reveals a hidden symmetry of dual conformal invariance. We learn an important lesson. Let go of spacetime. Then the math simplifies and new symmetries emerge. Remarkably, the new structures beyond spacetime are fully determined by permutations. As Nima and his co-authors put it, on-shell diagrams are fully determined by permutations, and hence the entire S-matrix of n equals 4 supersymmetric theory can be described combinatorially. The amplituhedron and other polytopes recently discovered beyond spacetime encode important properties of spacetime. For instance, the unitarity of quantum theory arises from the facet structure of the polytopes. In the cosmological polytope, for instance, unitarity follows from the way boundaries of the scattering facet factorize into products of lower dimensional polytopes. Moreover, Lorentz invariance follows from a contour integral representation of the canonical form, which exists for any polytope. To make a long story short, physicists have found that at the deepest level, scattering processes are determined by permutations and convex combinations of permutations. These convex combinations are the points of geometric objects called Birkhoff polytopes. These Birkhoff polytopes in turn form the basic cells of a structure called the positive Grassmannian. A linear map transforms the positive Grassmannian into the amplituhedron. The amplituhedron then gives rise to locality, unitarity, and scattering in spacetime. Spacetime is not fundamental. Beyond spacetime are permutations and structures based on permutations. But why? Permutations of what? No one knows. But we have a proposal. In agreement with Chris Fuchs, we propose that it is time to embark on a large research program whose outline is just taking shape. It hints of a world, a pluriverse, that consists of an all-pervading pure experience, as William James called it. Chris continues, expanding this notion, making it technical, and letting its insights tinker with space-time itself is the better part of future work. Quantum states, Cubism declares, are not the stuff of the world, but quantum measurement might be. To this end, my collaborators and I propose a pluriverse that consists of an all-pervading pure experience. Our pluriverse is a network of conscious agents that interact. Conscious agent is a technical term that I'll define in a moment. But first, here are some motivations for our definition. Physicalist theories of consciousness assume that space-time and particles are fundamental. These assumptions are false. These assumptions are rejected by the theory of conscious agents. Moreover, physicalist theories of consciousness, such as global workspace theory, fail to explain specific conscious experiences. Let's look again at what Steven Pinker says about global workspace theory. But the last dollop in the theory, that it subjectively feels like something to be such circuitry, may have to be stipulated as a fact about reality where explanation stops. If a physicalist theory stipulates conscious experiences, then, with a nod to William of Ockham, let's stipulate nothing more. Let's stipulate only conscious experiences. Let's show how space-time and particles emerge from this one stipulation. That's our goal for a theory of conscious agents. A theory of conscious agents must explain many things, including everything listed here. By Occam's razor, we want a theory that makes the fewest assumptions and then explains everything else. This is our goal in our definition of a conscious agent. The basic idea is that there is some world that influences the experiences of the agent. These experiences influence the actions of the agent. The actions of the agent influence the state of the world. The world influences an agent's experiences via a perception map P. The agent's experience influences its action via a decision map D. Its action influences the world via its action map A. It counter increments with each new experience. Formally, a conscious agent is a seven-tuple, WXG PDA N, where W, X, and G are measurable spaces. P, D, and A are Markovian kernels. N is an integer. The measurable spaces W, X, and G may, of course, have additional structures, such as metrics or vector spaces. We propose a conscious agent thesis. Every conscious entity and activity can be modeled by conscious agents. This is our analog of the Church-Turing thesis for Turing machines. We propose a conscious realism thesis. The world consists of conscious agents. This is a monist ontology. Here's how conscious realism works. Consider two conscious agents, Agent 1 and Agent 2. We take one of the agents, Agent 1, and replace its space W with the second agent, Agent 2. In this way, we can construct networks of 3 conscious agents, networks of 4 conscious agents, and networks of many conscious agents. Agents combine to form new agents. For instance, any pair of agents satisfies the definition of an agent, and thus is itself one agent. This is one way that agents combine. There are others, such as complete fusion, which I will discuss in a moment. Since any pair of agents is an agent, there is ultimately one agent. This agent observes itself. This one agent can be analyzed in a scale-free fashion into a network of interactions of sub-agents. If I'm an agent somewhere in the middle of the network, then agents below me may appear as my psychology, biology, chemistry, or physics. Agents above me may appear as social or spiritual. Notions of perception, action, self, and choice can be unpacked recursively within this scale-free network framework. Conscious agent networks are computationally universal. Anything that can be computed by neural nets can be computed by conscious agent nets. Networks of conscious agents are not restricted to computation. They may go beyond computation. For instance, their Markovian kernels may be defined over non-computable events. Some, but not all, of the asymptotic dynamics of conscious agents can be described by permutations and convex combinations of permutations. These convex combinations can be represented by Markovian kernels that are bistochastic. For such kernels, and only such kernels, the uniform measure is a stationary measure. The Markovian dynamics of conscious agents creates spacetime as follows. We first project the agent dynamics onto its asymptotic or long-term behavior. Some, but not all, of this behavior is captured by permutations and convex combinations of permutations. These convex combinations form geometric objects called Birkhoff polytopes. Birkhoff polytopes, in turn, are basic cells of the positive Grassmannian. A linear map takes the positive Grassmannian to the amplituhedron, discovered by physicists. The facets and volumes of the amplituhedron give rise to locality, unitarity, and the probabilities of scattering in spacetime. In short, we start with a network of conscious agents and use spacetime to code its asymptotic behavior. Spacetime is just an interface that some agents use to interact with other agents. To study the asymptotic behavior of interacting conscious agents, we can use their qualia kernels. The qualia kernel, Q, of a conscious agent is the composition of its kernel D followed by A followed by P. This kernel maps X to X. That is, it maps experiences to experiences. Thus, it describes how the agent's experiences evolve. Now consider the qualia kernels of two agents. Agent 1 has only one experience, red. Agent 2 has only one experience, green. Each qualia kernel can be represented by a 1-by-1 matrix whose only entry is 1. Now we combine Agent 1 and Agent 2 into a single new agent. There are countless ways to do this. For each way, we can write down the qualia kernel for the new agent. All of these new qualia kernels can be described by the matrix Q of xy, where x is the probability that the next experience of the new agent is red, given that its current experience is red. Y is the probability that the next experience of the new agent is red, given that its current experience is green. The space of all qualia kernels for this agent is the unit square. Each point of the square represents a kernel. The color at each point indicates the weights of red and green that characterize the kernel. These weights are given by the stationary distribution of the kernel. That is, the distribution mu that satisfies the equation mu q of xy equals mu. Each corner of the square is labeled with the matrix representation of its kernel. For instance, the lower right corner is the identity matrix. This kernel involves no interaction between Agent 1, who perceives red, and Agent 2, who perceives green. The upper left is the not matrix and indicates a cyclic interaction between Agent 1 and Agent 2. Most other points within the square are kernels with non-trivial interactions of Agent 1 and Agent 2. All kernels on array, as shown in this figure, give the same stationary distribution of red and green experiences. The Birkhoff kernels are the bistochastic kernels. Each row and column sums to 1. These are indicated by the line segment and dashed circles in the figure. These constitute the Birkhoff polytope B2. For these kernels and only these kernels, the uniform measure is a stationary measure. For any qualia kernel Q, we can compute a difference quotient, QQ minus Q. The difference quotient is 0 for each kernel on the dashed line, QQ equals Q. These stationary kernels capture all possible stationary measures of red and green experiences. since all kernels along array give the same blend. We can plot the difference quotient and visualize the flow of qualia kernels. Here we see that most of the flow heads toward the diagonal line of stationary kernels. For these stationary kernels, the parameter x equals the parameter y. So let's use a new variable, alpha. Then the qualia kernels become this. The stationary kernels drop rank. The two agents and experiences become one. We get a fusion of agents and experiences. Alpha is an index, then, for a one-parameter family of new agents, each agent having a new color experience that is a fusion, a convex combination of red and green. If, for instance, alpha is 0.5, then the fused agent can be depicted like this. It has a new experience of yellow. We can fuse any number of agents. If, for instance, we start with 3 agents, then the stationary kernels, and thus the fused agents, form a 2 simplex. The color at each point of the simplex indicates the new experience of the new agent. If we start with n agents, then we get an n-1 simplex of new agents and new experiences. The intersection of the stationary kernels with the Birkhoff kernels is always a single kernel, the kernel with maximum entropy, the n by n matrix whose every entry is 1 divided by n. That's all I'll say for now about the asymptotic dynamics of conscious agents. There is much to explore. Now for some closing thoughts. Here is the famous Necker cube. Sometimes it looks like this face is in front. Sometimes it looks like this face is in front. Which face is in front when you don't look? Well, neither, of course. The 3D cube exists only when you create it, and create the empty volume of space inside it. The same is true of all objects that we perceive. If space-time is not fundamental, then neither are its objects. They are icons that we create and delete as needed. Of course, to call them icons is not to endorse some classical notion of sense data. It is simply to recognize that local realism and non-contextual realism are false. Neurons, for instance, are 3D icons. We construct them when we look. We delete them when we look away. Neurons do not exist when they are not perceived. Thus, neurons cause none of our behaviors or experiences. So we need more money for neuroscience, not less. We must reverse engineer neurons. We must see how neural dynamics in space-time are projections of a dynamics beyond space-time, perhaps a dynamics of conscious agents. In like manner, your body is an icon, an avatar. You construct it and delete it as needed. You are not your avatar. The seer is not the seen. The hearer is not the sound. The distinction we make between conscious and unconscious objects is not principled. It is an artifact of the limitations of our space-time interface. According to conscious realism, we always interact with the dynamics of conscious agents. Sometimes this dynamics projects to icons in our interface that give us some insight into those agents. Other times, the icons give us less insight. An icon we call a human face is a useful portal that gives some insight into the consciousness behind. Cat and mouse icons give us less insight. The portal is getting dim. Microbe icons give us less insight still. The portal is quite dim. Rock gives us no insight into consciousness. The portal is closed, but this is no surprise. The point of an interface is to simplify and to hide. The distinction between conscious and unconscious processes in the brain is not fundamental. Your conscious experiences are not part of my phenomenal consciousness. That does not entail that you are unconscious. Similarly, many of my own mental processes are not part of my phenomenal consciousness. But that does not entail that these processes are unconscious. It just means that they are screened out by my interface. In like manner, the distinction we make between living and non-living things is not principled. It is an artifact of the limitations of our space-time interface. Can we reverse engineer our interface and figure out how to open new portals into consciousness? I think so. We already have one technology for opening new portals: having kids. If we can reverse engineer this, we might invent new portals. Some portals may look like artificial intelligence, but we wouldn't be booting up consciousness from unconscious circuits. We would be opening new portals to a pre-existing consciousness. If consciousness is fundamental and dynamic, then what is it doing and why? I don't know. The only idea I've encountered that seems deep enough derives from Gödel's incompleteness theorem. Gödel tells us that there is no end to the exploration of mathematical structure. If consciousness is all there is, then mathematical structure is only about consciousness and its possible varieties of forms. So perhaps consciousness endlessly explores its own possibilities and thereby knows itself. This sounds familiar to Max Tegmark's idea of a level 4 multiverse, but there is an important difference. For Tegmark, mathematics is fundamental reality. For conscious realism, mathematics is just the bones of the living organism of conscious agents. How might time emerge from the dynamics of consciousness? If this dynamics is stationary, then its entropy does not increase. But it is a theorem that any projection of that dynamics will induce an increasing entropy, and thus will induce an entropic time as an artifact of the projection. To be more precise, suppose that the Markovian dynamics of conscious agents is stationary. Then its entropy H does not grow, as shown by this formula. But if we project this dynamics using conditional probability, then the entropy of the projected dynamics does grow, as shown in this formula. The proof of this is simple. We note that conditioning reduces uncertainty, and so we can write this expression. By the Markov property, we have this expression. And because the process is homogeneous, we get our result. Thus, entropic time could be an artifact of the projection of a dynamics that has no entropic arrow of time. The Big Bang itself could thus be an artifact of this projection. If entropic time is an artifact of projection, then scarcity of resources more generally may also be such an artifact. If so, the appearance of evolution by natural selection, with its competition for limited resources, may be an artifact of projecting a dynamics that has boundless resources and no competition. Our definition of conscious agent assumes that there are qualia and actions that depend on qualia. Everything else on this list, such as the self and free will, is a problem to be addressed using networks of conscious agents. I have briefly discussed creating spacetime and solving the combination problem. Networks of agents that implement attention, short-term memory, long-term memory, categorization, and case-based planning are developed in a paper by Chris Fields et al. Titled Conscious Agent Networks. There is fascinating work ahead. Many thanks to my collaborators. Thank you for your attention. One thing live, in addition to this, and that is that one question you might have is the agent dynamics and its asymptotics had a lot of stuff in it. Birkhoff polytope was a measure zero subset. I'm only using the Birkhoff polytope to get to physics. So what gives there? And what I'm looking at right now is the possibility that we project all of the dynamics of the conscious agent asymptotics onto its own Birkhoff polytope. And then from that we get the physics. And again, that's all part of making this user interface. So the interface is supposed to delete a lot of information and only show you stuff in a format that you could use. That's very helpful. So perhaps what's going on is we have all this asymptotic dynamic stuff. It's coding along that one diagonal that have the stationary kernels, that's coding all the fusions and all the new qualia. Only one of those is actually in the Birkhoff polytope. All of the interesting qualia and fusions are happening outside of the Birkhoff polytope. So there's all this good stuff that's not being captured by the permutations and convex combinations that give rise to space-time. So it's going to be very, very interesting to look at that and to come up with a projection. But with that, I'll open it to questions.
Okay. Yeah, I thought your talk maybe had the wrong title. Instead of space-time is doomed, fundamental space-time is doomed. Because
Sure.
Just because atomic physics, for example, isn't fundamental, we don't say atomic physics is doomed. And so on, likewise, biology, chemistry, electromagnetism, whatever. So yeah, the various results you're pointing to at least offer some suggestion that space-time isn't fundamental. But I think the alternative that many people pursue in light of this is something like, I don't know, space-time emergence. Space-time is grounded in a more fundamental level. And at least in the philosophical literature I've seen, the dominant strategy here has been a form of functionalism about space-time, understanding space-time as basically grounded in patterns of interaction of more fundamental entities, whether it's strings or loops or causal sets or conscious agents, even. But once you're a space-time functionalist, once you take that kind of approach, then it's no longer quite so clear to me why space-time is doomed, leads to reductionism is doomed. Then the question is, well, why did reductionism actually need fundamental space-time? I mean, the dominant strategies for reducing consciousness have tended to be functionalist themselves, reducing consciousness to various causal roles and patterns of interactions and kinds of computation, which may or may not essentially require fundamental space-time. So from that perspective, you might think actually reducing space-time to some functional causal network is actually, at least it doesn't make it any harder to be a reductionist about consciousness. You might see it as playing into the project of reductionism about consciousness. I mean, I don't like reductionism about consciousness, but it's not clear to me that the move from fundamental space-time to non-fundamental space-time actually makes it any harder. I mean, maybe there are other reasons that you have for being non-reductionist at that point, but insofar as one was meant to lead to the other, I wasn't quite seeing how that worked.
Right. So when I say space-time is doomed, I'm just literally quoting the physicists, like NEMA. Right. So I picked up their own phrase. That's what they say in their lectures to their classes. That space-time it's been good, but it's over. Space-time is doomed. And NEMA is the one who then says that reductionism is also doomed, because the idea of reductionism is you go to smaller and smaller regions of space, you're getting more and more fundamental laws. Well, it turns out that you can only do that for a few orders of magnitude, and then you start creating black holes. So by the time you only go to 10 to the minus 33 centimeters, that game is over. Now, if it was 10 to the minus 33 trillion, I'd be impressed, but 10 to the minus 33, I'm not impressed at all. So it's like
whether reductionism is about size, right? You might think it's about reducing the less fundamental to the more fundamental, but once you give up on space, it can no longer go into smaller things. Smaller things.
Space. Absolutely no. But NEMA is very clear about that. So the reduction to smaller and smaller space-time objects with more and more fundamental laws for those space-time objects, that's doomed. But reduction to different kinds of explanation is not doomed, right? And so what they found is these new polytopes. So the amplituhedron, the cosmological polytope, the associahedron. What they're finding is there are these magical structures that in their facets, the facet structure, you code unitarity, and in the volumes of these coding scattering amplitude. So there are these platonic objects. They're not platonic solids, but they're polytopes that are just sitting there. And they don't know, there's no notion of dynamics on these polytopes. Polytopes are just there. But these polytopes, what makes the physicists excited about them is when you can go from billions of terms to one term, when you let go. So you let go of space-time. If you do it in space-time, the problem is Feynman says you have to do all of these loops for all these virtual particles because you're trying to force unitarity in space-time. And so you have to make all these, and for each one of those, you have to add a term. Well, reality doesn't care about that interface. Reality is something far, far deeper with symmetries that you can't capture in space-time, that dual conformal symmetry that I mentioned. So all of a sudden, if you let go of space-time, you let go of this weird straitjacket, and all of a sudden you see these deeper symmetries, and the math goes from 1 billion terms to 1.
So what these guys are saying is, okay, yeah, there is a new level of explanation. It has nothing to do with space-time. Space-time is this terrible data structure that we seem to be saddled with. We have to let go of this terrible data structure. And once we do that, now we see the symmetries and we get the math going to. So that's why they're saying, forget this whole physicalist space-time and reductionism in space-time. That just is not even interesting anymore. There's this whole new way. Now, where the whole thing is stopping, I think, is that they don't know what these polytopes are about, right? Why did God say, let there be an amplitude-hedron? And then, so they have no story about where these things come from. And that's where I'm saying the consciousness research has a way to plug in. They told us what you need to plug in. They say, look, if you can give us permutations, we'll give you all the way to space-time. So I say, well, I'll give you permutations from the asymptotic behavior of consciousness. And that way we get the whole story. So that's why space-time all of a sudden becomes irrelevant in terms of fundamentals, even to the physicists. Certainly to me as someone taking consciousness as fundamental. But even to the physicist, it's basically, for the younger generation, it's over.
But I think what I was saying was that space-time is also fairly irrelevant to most of the leading reductionist theories of consciousness that reduce things that, try to reduce consciousness to things like information or computation or causal relations. Very few of them, I think, give a very central role to space-time. So you might think, get rid of space-time, those reductionist theories are no better or no worse than they were all along.
Well, my understanding of, for example, IIT is that if there were no particles, there would be nothing to have integrated information.
I don't have any space. I mean, maybe it needs time. IoT does use time, it's true. It's not going to need anything like space, just causal structure amongst them.
Well, well, to the extent that they talk about brains having the right IIT and so forth, and physical systems having the right kinds of IIT, they seem to either be dualists or physicalists. And the other problem that I mentioned with that is that there's not a single success on a specific conscious experience. So what is the Q structure for anything? I mean, give me a Q.
I agree with this kind of point. This is very different from the point that stems from space-time.
Right. So I'll just say this: all of the theories that I mentioned, so integrated information, workspace, and OR, all of those, I think, assume space and time is fundamental, and that brains and other complex physical systems created. I mean, and I'm just saying we have to let go of space-time completely. The physicists are telling us that, and evolution by natural selection agrees. It's simply not a fundamental notion in any sense. It's literally just a convenient data structure that some of us use, but has nothing fundamental about it at all. So it's really, to use space-time and its objects is very much like saying, let's build a theory of consciousness based on earth, air, fire, and water, right? Have fun doing it, but
again, I think the global workspace theory is like Standard Haynes, because nothing in the global workspace theory involves any commitment to fundamental space-time.
It's just to an abstract functional.
Yeah, so it's an abstract functional rule which could exist whether or not space-time is fundamental.
Yeah, to the extent that you're an abstract fundamentalist, functionalist, I'm sorry, an abstract functionalist, absolutely. In practice, I mean, so in practice, many of them are physicalists, right? In practice, but if we keep it to strict functionalism, then, well, essentially, well, so here's the other thing where the issue about reductionism then comes into play, right? How does, for example, IIT work? IIT is saying when we have the right kind of complexity of certain systems like physical systems, then consciousness will be there. But that complexity, from this point of view, is merely an artifact of the space-time data structure that we use.
We have Larissa in the chat here now saying IIT is built on conditional probabilities.
Okay.
You don't need space, you don't need time, just dynamics.
Oh, well, then we're,
Larissa, did you want to unmute yourself and ask the question?
yeah, absolutely.
Sure. Can you hear me?
Oh yeah.
I'm sorry.
A little loud from the previous. Okay, go ahead, Larissa.
Okay, carefully. Yes.
Yeah, we're good.
Okay, yeah, I was, because of the criticism with the Q structures, I was wondering, so I mean, you had your green and you had your red experience, right? And then it was possible to combine them and to get yellow, and you build your agents and you create a larger space of possible experiences, right? But then what is the green and what is the red, right?
You're asking me in my system, what are red and green?
Yeah, where do the qualities come from?
Well, so this is all about what do you start with in the theory and what do you explain. So I'm not starting with complexity. I'm starting with qualia. So qualia are the miracle, right?
Okay.
Every theory has this miracle. You always have something that you assume and then something else you explain. So I'm choosing to have nothing at all like space-time or particles in space-time. None of that is fundamental. It's nothing. The only thing I have is the fundamental, starting point are qualia, and then this Markovian dynamics of qualia. That's it. That's my entire ontology.
So there's a certain basic set of basic qualia from which you can build the rest.
Well, so the qualia are there, but it turns out that certain qualia can be viewed as when two agents interact and fuse, they also create that, they have that qualia. So there's this deep relationship among different qualia.
But do you have any idea yet on how many different types of basic qualia you need?
Oh, it's unbounded. Right, the range of possible qualia, like the range of potential states of space, and in some versions of space-time where space goes up to infinity, is unbounded. So I have an unbounded set of qualia, but only one category of assumption, namely there are qualia. That's my only assumption. There are qualia.
Okay. So to be fair, then you have a way to construct experience, and some build on these basic experience, but it's not like there's an explanation for where they come from. It's just that's what actually exists, right?
Well, no, the explanation is this. The explanation is I have a definition of a conscious agent. So that's anything that satisfies that definition is a conscious agent. When I have two agents interact and look at their asymptotic behavior, when it goes to its limit and reaches the stationary point, it drops rank. The kernel drops rank, and it satisfies the definition of a single non-composite agent. So this falls directly from the mathematical definitions of the theory. So this is a theory that's completely principled. I'm not asking for more complexity. I'm saying anything that satisfies my definition of an agent is an agent. When agents interact and go to their stationary distribution, then and only then do they satisfy the definition of being a single agent. Before that, there were two agents that were going back and forth, like there was red experience and a green experience, a red experience and a green experience. So there was one formal agent, right? It's not an interesting one. It's a product agent, but that agent has two different experiences, red and green. But when we go to that place where the kernel drops rank, then the mathematics is telling us you no longer can talk about a red experience or a green experience. There's only one experience. That experience is a convex combination of the two. So this is falling. It's not an add-on. It's a direct implication of the basic definitions. And notice it has nothing to do with complexity.
And when an agent gets subsumed, so is it gone then as its own agent, or is there multiplicity?
Multiplicity. Because, well, I can also talk about two agents as well as the one. So, I mean, I can talk about, for example, me as a single person, but I have a left and right hemisphere, and some people, the left hemisphere believes in God, and the right hemisphere is an atheist. So they can be very different and yet be part of one. But notice that if I am fundamentally thinking in a reductionist manner, and I'm saying there are these fundamental entities, and I need to get complex interactions of them before I can get something that's complicated enough to be conscious, or the complexities related to the consciousness. That's related to the reductionist approach. I'm saying that, and the appearance of why that seems to work in our space-time interface is an artifact of the limitations of our interface. When we see something like a proton, there's not much evidence for consciousness not because we're not interacting with consciousness, we are interacting with consciousness. It's just that our interface is dumbing things down. We can't see much about it. So IIT from this point of view is really doing is it's showing how complexity in the interface is giving us more and more insight into the consciousness behind. But it's not about the creation of the consciousness. It's about how much our interface is giving us insight into what's behind. Like if I have a single a pixel on my Zoom screen of Chris Fuchs' face, that one pixel is not going to give me much insight into Chris Fuchs' consciousness. But if I have enough pixels where I see his whole face, then I'll get more insight into his consciousness. It's not that somehow the more pixels you have, the more consciousness you have. It's not that. It's that the more pixels I have in my interface, the more I can see through the interface to the consciousness that was always there. So it's a very different mindset than IIT. You're not building consciousness out of complexity. It's just that complexity happens to be the way that you get clearer because of interfaces, the way interfaces work. One pixel doesn't give you much information. Complex pixels give you lots of information through on the other side. So the whole spirit of this is entirely different from anything that's trying to build out a complexity or orchestrated collapse of microtubules, things in space. This is saying, let's start with consciousness on its own and nothing else. Stipulate one thing and only one thing, and build space.
But you said that then each hemisphere also gets its own consciousness, probably, right? And wouldn't that also be true then for basically every subset of neurons within my brain also?
Yes. So the idea is that the only thing that perception is about is consciousness. That's the assumption. That's the pluriverse assumption.
And so what makes me? It just happens. It's an illusion, or like I could be anything, or is there a reason?
Well, so agents are genuine units in ontology, right? Agents are, they really are agents. The notion of a self is different. So the notion of self is not part of the basic definition of a conscious agent, nor is a whole bunch of things, learning, memory, problem solving, intelligence. All of these things are not part of the basic definition. The definition is on purpose stripped down to the bare essentials that I thought the bare minimum we would need to boot up a theory of everything from that, including intelligence and the self. So we do owe everybody at some point a theory of a self. What does it mean to have a self, or the illusion of a self? Right now, these agents aren't necessarily self-aware. There's no reason for any agent to have any awareness of itself. It's aware of experiences. You can therefore maybe build models and have we can build conscious agent networks that can do anything that neural networks can do. So we can build theories of learning, memory, problem solving, and intelligence and cells from that. But these are not fundamental. Only qualia are fundamental, and probabilistic transitions based on qualia.
Yeah, I guess I'm just, I'll stop. Thank you. I'll talk to you later.
Sorry, I didn't want to interrupt you, Larissa. I thought you had finished.
Okay, last one from Bernardo.
Don, I couldn't follow up a bunch of things because you're referring to literature I'm not familiar with. But I think the crux of the matter is how can we have structure without extension? How can we speak of complexity, diversity, and structure if there is no extension? I can see that cognitive associations based on meaning can exist without extension. But when you talk about multiple and different conscious agents prior to extension, prior to space-time, in what sense are they different conscious agents? I mean, Schopenhauer is famous for having claimed that without extension, there is no differentiation, there is only unity. So what makes a conscious agent different from another prior to extension?
Well, I think the same thing that makes one mathematical function different from another prior to extension, right? The functions just are the functions. The sine function is different from the cosine function. It's different from whatever other function you want. I don't need to have any arbitrary space that these things are put in. I don't see any trouble with individuating things outside of space-time at all. We do that in mathematics all the time.
That's grounded in the meaning of the functions. Are you saying that different conscious agents are different mathematical functions?
Well, so
So there cannot be
agent,
two identical but different instantiations of a conscious agent. I mean, like two cars of the same make, year, and model. They are identical, but they're different. Can there be two conscious agents like these two cars?
sure, yeah, right. So there's no ambient space that prevents that. So space is just a user interface that some agents use to interact with other agents, but I don't need any prior notion of extension. Some agents may use extension as a convenient shorthand to help them with their interactions, but I don't think I need that at all.
But don't we run the risk that we are grounding everything in linguistic abstraction and not having an explicit conceptualization of what that means? Differentiation without extension is tough. If you really want to understand what you're saying and not stopping at linguistic conceptualizations that are floating in the air, do you share with me this impression that it's difficult to ground differentiation without extension?
I don't share that at all. I think that's very easy mathematically to talk about multiple agents, look at their asymptotic behavior, boot up spacetime, for example, in the way that I just described. We can start with agents and get spacetime coming out. We can get extension out of it in the way that I outlined. And I can certainly individuate agents by differences in their spaces X, G, and X and G, for example, and their kernels. So if two agents have different Markovian kernels and different spaces X and G, then they're different agents. If they have the same, they're the same agent. And I just don't see any philosophical problem here at all.
If mathematics is a description, then what is it describing, right? Unless it's the Tegmark approach to say that mathematics is the foundation of being. It's pure abstraction.
Okay, no, that's an important question. So agents are agents, and the mathematics that we've written down is just mathematics, right? So
what does it describe? So what does the mathematics describe?
It describes real qualia that are changing. So the thing that's real here are the qualia, and my mathematical description of that, our mathematical description of that is just a description, right? The math is never the territory. So in this case, the math is not the territory. So this is about qualia and changes of qualia. That's what it's about.
So could there be two conscious agents that are both qualia red, and yet they are two conscious agents that are red? Two experiences of red that are identical and yet distinct as two different conscious agents.
Let me make sure I understand your question. So we have two agents now, and you're saying?
Yeah, you said what the mathematics describe is qualia.
Right.
So the conscious agents are qualia. So I'm imagining a quail red. Well, conscious agent A is quail red. And conscious agent B is quail red as well.
No. Okay, so yeah, so I'll be very, a conscious agent is a seven tuple. Right, so it has more structure than just the qualia because it also has these Markovian kernels. But a conscious agent could have, for example, the simple conscious agent that I talked about was this full conscious agent, but it had only one point in its space X of conscious experiences. So X had only one point. So I was just using that to be very, very simple. But the agent is going to have more structure than just a single qualia in general. You'll have the qualia and the kernels.
That's the thing. What is that structure then, given that it's not extended?
It's a structure that is able to create extensions if it wants. It can make spacetime as a user interface if it wants.
I understand it, but I'm trying to pin down what that structure is outside extension. I understand it wants to create extension, but it needs to be something prior to extension. And it cannot be just a mathematical equation because that's a description of it and not it.
Okay, one last follow-up, Don.
Okay,
finish on this one.
Right, and we'll have to talk some more about this, Bernardo. Yeah, so Yeah, well, what's really there are these structured interactions of Qualia. That's what's really there. And space itself is just one form of Qualia. Differentiation in space is just one form of Qualia. So we may have differentiation in spatial Qualia, or we may not. That's, spatial Qualia are not that special. And but I guess we should drop it there and
All right.
we'll go offline.